Hello, friends. Welcome to this month's monthly webinar, Micrometrics Every Performance Engineer Should Validate Before Sign Off, right? So, friends, this is a monthly webinar series we are conducting. So in this today's webinar, we are going to be talking about what are the key micrometrics that as a performance engineers we should validate in our performance lab. Why we need to validate, what is our reason for that, and how to source these micrometrics. So what are the benefits of them? That's what we're going to be discussing in this session. Okay, so we will get started. Okay, so friends, whenever there is a performance problem happens in production environment, right? Our management asks this favorite question. The question is, why didn't performance tests catch this problem? Right? Have you guys encountered this question? Management asking us, why didn't performance tests catch this problem? Why we are seeing this in the production? What is the performance test doing? Have you faced this question? If so, you're welcome to put in the chat, right? And then also feel free to ask any questions at any time in the chat. Put it here. I will answer all those questions towards the end of my talk. Okay. So, friends, when this question is asked, what is the typical response from us, right? What are the typical response we give? The first response that we give is, in the performance lab, we use synthetic data, which is not the actual replica of the production data. See, what do I mean by that is, several years before, I used to work for a very large financial institution, it's a very large bank, right? So in our and typical customer in US has like a 2.5 accounts. That's what a typical number of accounts a customer has. So in our performance lab, we were modeling our test based on that 2.5 accounts. That's our test data it looks like. But there are some exceptions, right? Say, for example, there are some customers who have like a 250 accounts. There are some customers who have like a 250 accounts. When those customers sign in and start to use the banking application, it really kinds of stresses out several parts of the application. Whether does it have enough number of threads, whether they have enough number of connections. What if two such customers comes at the same time? Can our application handle, right? So those are real world data that is oftentimes not modeled in our performance lab. That is one thing. The second thing is, our performance is heavily influenced based on the traffic pattern. See, in production, we may see a sudden burst of traffic going up and then coming down. And then there may be maybe a very less traffic for a long period. And then a burst can happen. Whether are we modeling those kind of traffic patterns in our performance lab, right? Because those play a very key role in detecting the performance problems. Probably we don't have that. A lot of our performance labs does not have that kind of a data. We work on the synthetic data, right? That is one of the response we give to our management. And the second response, what we tell to the management is, our performance environment is not identical to production environment, right? See, our hardware configurations of our performance lab is different from the production. Are we looking into the OS, whether it is the exact same version, whether it is have the exact same kernel patches? Maybe the production is different. And is the load balancer settings in the performance lab and the production, are they same? Are there the connection, the timeout settings, the connection settings, are all they identical? There is always a variation. Since if there is a variations is there, it's not identical. So it's going to be making hard our performance lab to catch the problems, right? The next thing what we report is, see friends, a lot of performance problem does not happen immediately. Say we're going to get an out of memory error in production. It doesn't happen immediately. For an out of memory error to happen, there is a leak building up in your application over a period of time. There's a leak is building up over a period of time. And in the test, an application has to run for several hours. Sometimes an out of memory error happens. If the leak is very small, very acute, it has to run for several days. for out of memory to happen. Are we conducting such long running endurance tests for a few days in the performance lab? Most likely not, because that is another reason we cite. And then the next important reason is absence of the real world chaos in our performance lab. See, in production, maybe suddenly there could be a network glitch can happen. In production, suddenly a load balancer can misroute the transactions. There could be a back-end slowdown. Are we simulating such real-world chaos in our performance lab? In our performance lab, most likely, you see, some of us are doing it today. So we have the chaos engineering practice. We are simulating artificial problems and then trying to see whether our tool is able to, whether our application is able to handle. But several of us, we are not doing that. So these are typical reasons we cite when the management says why we didn't catch the performance problems. See, friends, these are all 100% valid, legitimate reasons, right? These are one of valid, legitimate reasons why still after our rigorous performance test, still why the problem shows up in production. But friends, I want to place an counter argument to this. Friends, whatever the problems that we see in the production, right? They happen in our performance lab as well. Despite all the reasons I told earlier, still, though, I would like to place a counter argument that whatever the performance problem that we see in the production still happens in our performance lab as well. But it happens at an acute scale, right? It happens at a small scale, it happens at a granular scale, which is not big enough to catch our attention. I'll show an example. I have some examples to show. The problem which manifests as a big outage in production still do happen in a performance lab, but they happen at acute scale, but they're not big enough to catch our attention because in our performance lab, we primarily monitor macro metrics. That's what we monitor in our performance lab, right? What we are monitoring today on what are the criteria in which we are certifying the release. Like we primarily look into these macro metrics: response time. What is my average response time? What is my 95 percentile response time? What is my overall memory utilization? What is my CPU utilization? Whether it is degraded from my previous release. So that's what we check, and based on that, we do the certification, right? But friends, these macro metrics are not good enough to capture the problems which is happening at an acute scale, right? They're not good enough. Say, so let's see what is this. Okay, and then what is this micrometrics? How is it different from the macrometrics? See, friends, the macrometrics are more reacts to the problem. That is only after a memory has leaked. We got an out of memory error. We're going to see the memory utilization going on, right? Only after some threads are getting blocked and the threads gets built up, then the response time is going to degrade. These are more reactive measures, macrometrics. But what we're going to show in this session, what I'm going to discuss, the micrometrics, they can predict the outages, right? So that is the primary difference. So let's look into it. So I want to give an equivalent analogy. Say we all go to doctor's office, right? We all go to hospital for general checkups, right? When we do that, when you go to doctor's office, doctors, or doctor's assistants, they basically check our body vitals. Like when we go, they check for the blood pressure or the body temperature or the pulse rate. So these are kind of macro metrics, right? These are very high level metrics, but only they don't tell. So this tells me only that the problem has already happened, then it's going to tell. But doctors also do some lab works, right? So they do blood samples. They draw blood samples to see how is my keratin level, whether am I susceptible to high blood pressures and heart attack is going to show up. And they may look into X-rays, right, to see what's happening inside my body. Instead of looking what is outside, they start to look inside what is happening in my body to see whether any problem, what is the problem and how serious it is, right? Similarly, in our performance labs, these are macrometrics that what we are looking, response time, CPU and memory. But there are micrometrics like a GC behavior, object creation rate, GC throughput, GC pause time. thread patterns, thread state, TCP/IP connections, and then error trends that is happening in the application logs. If we start to pay attention to these micrometrics can tell me, even if the problem is happening at acute scale, it can tell me whether it's going to manifest as a big production outage. So let's look at with real examples. So here, friends, here there are 9 micrometrics. Let's look at few of the micrometrics in this session. If you want to see all the micrometrics and the details of that, you can go to this link, which is given here. So, friends, the first micrometric that what I want to discuss is garbage collection behavior pattern. So what is garbage collection behavior pattern? Look at this. Friend, this is an garbage collection behavior pattern of an healthy application. You can see the request is coming, the memory is building up when a full garbage collection went. In a red triangle here, it indicates a full garbage collection. It ran, and the memory dropped all the way to the bottom. And now once again, the request is coming, the memory is building up. When a full garbage collection went ran, the memory dropped all the way to the bottom. You see this beautiful sawtooth pattern going up and down, right? It's a sawtooth pattern going up, down, up, down. Look at this. If I try to draw a line connecting all the bottom points, it is this black dotted arrow, right? This arrow mark, if you see, it is almost going at a 0 degrees. It's going at a 0 degrees. This means if it goes at 0 degrees, it means it's an healthy application. Its application is quite healthy. There's no memory leak happening. But if application is suffering from a memory leak, this is how the garbage collection behavior pattern is going to look like. So you can see the memory is building up and a garbage collection ran. When the event ran, it dropped here. Memory dropped here. It's going up and dropping, going up and dropping. But if you see, my friends, the very first garbage collection event, the full garbage collection event, when it ran, the memory dropped to 4 gig. After that, it dropped to 4.5 gig, then 5. You see, it keeps on the memory is not settling down to that initial 4 gig, like how it happened in the previous case. It didn't come down. Now it just keeps on going, building up, building up. After a point, the garbage collection keeps on running, but the memory will not come down at all. So when it keeps going like this, when it reaches the ceiling limit, that's when we are going to confront out of memory error. When it reaches the ceiling limit, we are going to get out of memory error. Friends, this out of memory error does not happen immediately, right? Most of the out of memory error takes time to build up. Sometimes it could be several hours, sometimes several days, sometimes it can be even few weeks for this to happen because the leak is happening at a very slow phase. It may take several days for out of memory to surface. The question is, in our performance lab, are we conducting a test, such a long-running endurance test? No, most likely not. But my friends, if we start to look at the trend, look at the trend. The trend here is the memory is starting to go up. It's starting to go up. It's never coming down. Probably in our performance lab, we are running a short test, probably a 1 hour or a 2 hour test. Maybe this is what we'll end up seeing. We'll just see it. You see this red line. Only till this red line we'll see. Oh, what we are looking in a performance lab, we are looking at our memory, CPU, and response time. Memory and CPU will not degrade. The memory, we see memory also we look at the number. Oh, memory is whatever is going to be configured as XMX, what we configure, the max size, that's what then we certify, okay, good. But if we start to looking at the trend, the DC behavior, you can see it's starting to go up like this. And if it starts to go up like this, and if it's not settling down like in the previous graph, that means it's an indication this application is suffering from an acute memory leak. If I certify this application to production, then it's going to build up like this, and I'm going to have an out of memory error in production. So if you start to look at GC behavior pattern, and if you see this trend of going like this, then you want to question the development team. We see this increasing trend. Why is this? Why it's not addressed? Is some leak got introduced? We want to hold the release. We don't want to certify it, right? So this is the first behavior. This is the first metric that we discussed. And the second metric that what we should start monitoring in our performance lab is TCP/IP connection count and states. What is TCP/IP connection count? Right? All our applications, connects with various backend system of records. And there are several front-end customers who are connecting with us. So let's say in a new release, your developer fails to close a connection, which is a very one of the common reasons for performance problems. A developer, we write new code to make a backend call. What if a developer doesn't close that connection after using? Then the connection will start to build up. And it takes quite a long time for the build up to happen and then it to burst, right? But in our performance lab, we run the test for a couple of hours. At that point, we see everything running fine because the connections are not built up enough to break the application. So similarly, but what happens? Your developer has introduced too many connections to the backend system. Like say earlier, he was just making one call and then it was going and coming back. Now he has made it very chatty. He's making a lot more calls. And maybe when if he's making a lot more calls, that means when your traffic volume comes very high, right? Say if there's high traffic volume, whether can your backend system can it handle such a load? Question mark. If we start to look at TCP/IP connection, this is a micrometric that I want to share. Number of TCP/IP connections my application is establishing with the backend systems and also with the front end systems. And then in what states they are, we want to look. See, in the previous release, if I was only establishing 100 connections with this particular system of record, whereas now in this new release, I'm making like a 200 or a 300 connections. That means we need to ask the developers, oh, why we are seeing 2x, 3x more connections being established. It wasn't the case in the previous release. Why was it? And then another thing also what we want to ask is, we want to look at the TCP/IP states. See, here is a table which reports what are the hosts to which my application is connecting and what is a connection and what states it is, what TCP/IP state it is, right? Say, suppose if accidentally your backend system is not closing the connection or your application is taking very long time to close the connection, right? Even or there are some network issues going on, there are some network settings are not right. That means you're not going to see the connections to be dying down. You may see lot more connections at timed wait state rather than exiting. You will start to see in timed wait state or a fin wait state. So you want to check, oh, how many connections I had with this system of record in the previous release, and what is it? Whether the connection count is more or is the same, or whether it has increased. If it is increased, we want to question. Okay, if it is same, then we want to look in what state they are. Are we seeing lot many in timed wait, closed wait, fin wait? Then it was not in the previous release. Then it is to subject for questioning the development counterparts. Okay. So this is the second metric, the TCP/IP connection count and the states. And then the third metric that what I want to bring up here is the thread patterns. See, friends, the threads are like the blood system of your body, blood system of your application. See, whenever any of our organs, let it be the heart, kidney, liver, or anything, if there are any issues in those vital organs, there will be a reflection on the blood. The chemical levels, the other things will be different in the blood. So similarly, most of the problems, let it be a garbage collection process, or it could be a backend slowdown, or there could be a memory leak, anything, it will be reflected in your threads. But the question is, we need to equip ourselves to understand how to analyze that thread's behavior, right? So we want to look into the thread's behavior. Was one more micrometric that we need to validate in our performance lab. So, for example, I will tell you how to get these metrics, how to source them. But here is an analysis report of your threads, right? This report tells me how many threads are there and in what states they are. See, now if I'm seeing in this new release that I'm working on, I'm certifying, I'm seeing like a 2,770 threads are there. But friends, we don't look into the thread counts in our regular certification process. But if too many threads are there, right, we will get out of memory error, unable to create native threads. But what if if there are a lot of threads in a runnable state, then your CPU will start to spike up in production. So you want to be looking what was there in the previous release and what is now, or whether thread count has increased. Or are there too many threads in a runnable state? Or there are too many threads in the blocked state? If blocked threads are building up, that means indicating application is getting stuck. It will result in outages if you run it for a longer period. So you want to look into the thread states and the thread behaviors. Say, I want to give a quick example, right? Uh, it's a real world case study that I'll share it with you. Okay, friends, look at this. This is a real world case study. Here, this application is having like 1,859 threads. Normally this application in the previous release and all, it would have only like a 300 or 400 threads. That's what it was having. But now suddenly we are starting to see such a high count. To see why it is, here the thread dump analysis is reporting, even though it has like 1,800 plus threads, right? Here, more than like 1,700 threads, which is like 92% of the threads in this application, are stuck waiting for response from the Oracle database, which is one of the primary database to which this application was connecting. After noticing this, then inquired, it apparently turned out in this new release, the development team upgraded the jar file, upgraded the JDBC driver. They upgraded a new version. That new JDBC driver adds some bugs, issues in that, due to which it was spawning threads. So this wouldn't be caught in our regular certification. The threads build up. It's not going to come to visibility in our 2 hours test. But only if it's going to be running for a longer period, when it starts to build a very large amount of threads, then it's going to result as out of memory error, unable to create new native threads problem in the production. So even if it's at acute scale, if we can look into this, then we can catch the issue and then it can be reported. Okay, so now I'm moving along. The fourth metric that I want to share, friend, this is something very favorite to me. Error trends in the application logs. In the performance lab, most likely we don't look into our application logs at all. But friends, application log is one of the vital artifact even today used by the development team to troubleshoot any production problems, right? Are we looking into what type of errors are happening in your application log? Whether are there any changes in the number of errors? Are we starting to see new type of errors in the new release? We should start to look into that. See, here, yeah, let's look into the actual application error trending, right? So let me go here. So here it is. See, friends, here it shows, oh, in this new release, I'm seeing 7. Okay, even before going in here, let me ask a question. People in the chat, please put. When an out of memory error happens, will your application crash? Will your application exit? The question, I'm asking a question. If an out of memory error happens, will it crash your application? Will your JVM, will it exit or can it still keep running? How many of you people say yes? How many of you people say no? It's an interesting question. See, friends, let me tell, even when out of memory error happens, it will not crash your JVM by default. You can configure some special JVM flags to make that happen, but by default, JVM will not crash the JVM. It will not crash. Can still keep running. So, friends, even if out of memory error happens today, it is reported in our logs. It will be reported in your performance logs, but we don't look into the performance log. Are we looking at application logs? We don't look. But if we start to look the logs, look at this. Here, oh, I'm seeing like a 742 null pointer exceptions, 120 string index out of bound exceptions, 42 file not found exception. And maybe if out of memory error has come, it's not there in this test data, it will be printed here. Take this, compare with the previous release. Are you seeing any new type of errors which was not there before? If that is the case, bring it up. And there are like sensitive errors like a stack overflow error or an out of memory error. If that shows up, you want to question the development team. Oh, it's starting to happen. Question them, challenge them, fail the release, don't certify, right? So you want to look into your log trends, what's going on. This is all often missed. We don't look into that in our performance lab. Okay. So now, friends, there is 9 metrics I told. I discussed only 4 in interest of time. I wouldn't be able to go to the other metrics, but there's a link is given. You can look into it offline. Okay. Friends, now this brings an interesting question. How to source these micrometrics? How we can get this? Friends, we do have an open source script. It's an open source script. No licensing is attached. It is an Apache license. You are welcome to use. So here, let me open. It is available and published in GitHub. Look at this, my friends. So this one script, when you trigger, it's going to it's going to capture like a 360-degree artifacts from your application, right? Uh, so look at this. When it's very simple script and it is platform agnostic. It can run on Linux, Windows, Mac, Docker, Kubernetes, OpenShift, right? We are also looking at supporting other platforms as well. So when you trigger this script is going to capture you a 360-degree data from your application stack. See, look, it's going to capture the garbage collection log, which is going to get me the GC behaviors, thread dumps, which is going to give me a thread behavior, heap information, what are the objects created. And then here it's going to look at this, it's capturing the application logs, right? It auto discovers, you don't need to do anything. It auto discovers what all the application logs to which is writing and then it picks it up. And then netstat, which is going to give me the network information. Like this, it captures all these 360-degree data. And then it's going to bundle them as a one single zip file. And then what you can do, you can take the zip file. And then once you have the zip file, you can upload it to the ycrash tool. So through this tool, like let me show you. See, here is this tool. Here is a tool. In this tool, when you trigger the script is going to create a bundle zip file. You can upload the zip file here. When you upload the zip file here, the tool is going to analyze it and then it's going to report you and root cause, it's going to report you an analysis report. See, it will be reported as an incident, it will be reported here like this. So whenever you upload, it's going to be reported as an incident. So now let's look into one of the incident report. So once you upload, it's going to create this report. In this report, here you're going to see there is this garbage collection analysis. Oh, this analyzes the garbage collection behavior, and then it reports what's going, whether the consecutive full GCs are happening. If consecutive full GCs are happening, it's going to result as timeouts. If it runs, that means GC is continuously running. If GC continuously runs, that means the JMU is going to be paused. If JMU is going to be paused, that means the timeouts are going to fail. And in production traffic, it's going to be more visible. And what is the process and what is the GC trends, right? I can look into this. And what is my threads? How are they behaving? What is the count? What is the size? All these behaviors are reported for us here. Like what is my TCP connections? How much connections I have and in what state they are. Whether is there's any changes, I can look into that. So here is my application logs. What are all the new errors that got introduced? Whether it's different from the previous one or the same. I get to see this. So everything, all the metrics, the micrometrics, whatever we discussed is present here. So this report is pretty intense. It has a lot of data. So here is a table which summarizes, these are the 9 metrics and how to get these metrics, from which part of the report gives you these metrics. Like, okay, the GC behavior pattern to get this and go to the report, go to the garbage collection report and go to the problems. Object creation rate. So we are just listing down from which part of the reports you want to source these metrics. Take it, you want to compare in between the previous release and then this release and see whether there's any arbitrations, any massive difference. If that is the case, we don't want to certify the release. Okay. So friends, And now, what is the another reason for okay, first reason why we want to monitor micrometrics is so it can forecast the problems, which can forecast the production outages. That is one very valuable thing. The second valuable thing, what micrometrics provides to us is it not only detects the problem, it also finds solutions to complex problems. It can find solutions to complex problems. Today in a performance lab, several of us, we say, oh, the release is broken, which is very valuable. We are detecting, okay, there's a problem, we are reporting. But it will be nice to say to development team, what is broken? Instead of saying it is broken, it will be nice if we can say, oh, this is what is broken. This is what is causing your application to degrade. It will be even more valuable. We'll become even more valuable to our organizations. So here is an example. See, sometimes your thread can be blocked by other thread. As a thread can acquire a lock and it will not release that lock. If the thread doesn't release the lock, then other threads which is coming behind, they're going to be getting blocked. They wouldn't be able to move forward, right? So in your performance lab, when the traffic volume is less or when you're running for a short period, maybe number of threads that is getting blocked may be small in number. But in production, the number of threads going blocked is going to be very high. And if number of blocked threads starts to build up, that means no more threads are going to be available to process the customer transaction. That means it will result as a massive outage in production. In a performance, if we see a lock and a small number of threads are blocking, then we want to report it to the development team. We want to say, oh, hello, developer. Here, let's say when you analyze this thread dump analysis report, right? The tool automatically it analyzes the thread dumps and then it's going to report you what threads are blocking what other threads. Here is an example. It tells, oh, this thread is blocking like 646 threads. Here we say in simple English, we say this class, this method is blocking 646 threads. So these are the 646 threads which is blocked. And this is the culprit threads stack trace, which acquired the lock and did not release it, due to which other threads are coming, they're getting stuck. So now if we present this kind of detailed, granular, precise information to development, they will think, oh, wow, what happened to our performance team? Now they're starting to report the actual solutions or root cause, right? It will be very valuable information for them, right? Okay. And then also, not only this, here is another example that I want to share. See, friend, this is a real problem that happened in an enterprise. See, look, this is the garbage collection analysis, right? This is a garbage collection analysis report. Look at this, my friends. So here is this application. Let me just zoom in. So this graph reports me, see, when a garbage collection run, it stops your application. So this graph reports me how much duration it's taking, how much time that each GC event is taking to complete. So how much time that each GC event is pausing my application. So when garbage collection run, it stops. And this graph tells how much time it is stopping. And if stop time is very high, that means during that time, if any transaction comes, the customer will not get any response. So take a look at this example. Look at this. I'm moving my mouse cursor. Here it tells there's a garbage collection event. It ran at 11:46 a.m. At 11:46 a.m., this event ran and it took 14.3 seconds to complete. It took 14.3 seconds to complete. That means this 14 seconds, if any customer transaction will come, he's not going to get any response. And now if you see, I'm moving to the next point. The next GC event ran at 11:52, which is 6 minutes later. And once again, it is stopping for 14 seconds. Another, from here, like a 7 minutes later, once again, it's stopping for 14 seconds. Why it is stopping for such a long time? That means if you're going to stop for such a long time, that means customer transaction are going to be jeopardized. So when these kind of things happens, the tool gives you recommendations of what to do to address this. See, the tool gives you a recommendation. See, here it tells, it looks like your application is experiencing long GC pauses. To improve it, consider decreasing your end generation size. It gives you a recommendation. Look at this, how this application they have configured. Look, they configured the young generation size to be 14 gig and then the old generation size to be 14 gig. They allocated equal size. So the tool, based on its analysis, is asking to reduce the young generation size. So now this team, they reduce their young generation size. Now let's look at that reduced report. They reduce the young generation. Look, they dropped the young generation from 14 gig, they reduced to 1 gig, right? Once they did it, look what's happening to this GC durations. See, the most of the GC durations now are settled down to this milliseconds level. Earlier it was average was 14 seconds. Now if you even see the highest one is to only 2.8 seconds. But most of them are settled. Earlier, the most of them was 14 seconds. Now most come to milliseconds. And only few occasionally it is going like this. Right? So that so you can not only, when you analyze the micrometrics, you're not only going to forecast the problem, you can also give solutions to the development counterparts on how to go about fixing them. Okay. So now I'm moving along. So friends, I want to share, say if at all you want to consider investigating this micrometrics in your performance lab, I want to share a best practice with you. The best practice is, let's say you're going to run your performance test for a 1 hour window. Let's say that's what you're typically, I've seen most of the organizations running for a 1 hour window. When you're going to run it for a 1 hour window, what you want to do, trigger this YC360 script, which captures all these metrics, all these 360-degree data, trigger it at the middle of the test, trigger at the 30th minute, because that's when you're having the peak traffic volume is going. A lot of bottlenecks starts to show up when there's a peak traffic volume is when there's a peak traffic volume. If you take a thread, if you take a dumps at that time and do the analysis, it can help you to forecast the problem very precisely. So do it at the middle of the test. And you want to also take a second snapshot of the data at the end of the test, once the test has completed. At the time, take it. Because when you take at that time you want to see whether all the connections has it been closed, is all the objects that has been created, has it been garbage collected, whether all the threads that are pinned to process the transaction has it come down. So you want to do that, right? So I want to share this best practice. That is, take it at the middle of the test and then at the end of the test, and then take the report and then compare with your baseline with your previous release. Okay, friends. So friends, with this, I'm coming to end of my talk. But before that, I just want to share with you one. Friends, this micrometrics, whatever we discussed now, there is this garbage collection, the threads, inner state and all, is not a very common knowledge. I can tell you, I can bet you. If there are performance engineers in this call, go and talk with your development engineer. Go and talk with your engineer and ask him, what garbage collection algorithm is our application using? You ask how the threads are getting blocked. Ask these questions. You'll start to see a question mark question mark flashing on their face to several of them. So, but this is a very deep knowledge held only by top 1% of engineers, I can say. I want all of you to become the top 1% of engineers. Right? I want to wish you all the good luck for that to happen. Okay, so friends, in case if you're not bored with this session and if you want to learn more about JVM performance engineering and tuning, here is an online class which is available. It has like a 8+ hours of course materials, which will facilitate you to become a better performance engineer. It is available online. You can watch it at your convenience, right? You are welcome to take advantage of it. Okay, so friends, thank you everyone for attending this month's monthly webinar. Thanks a lot.